Hi everyone, thanks for joining. Welcome. First, I'd like to thank to AWS for the warm hosting. It's really great to be here, so thank you everyone for joining and for hosting us. I'll introduce myself briefly. My name is Tal, and I'm part of the lakeFS team. I'm leading one of the teams in our R&D group. And in addition to being part of the lakeFS team, I'm part of the organizing team of Big Things. So for me, being here with you, speaking at a Big Things meetup about what we do at lakeFS to execute on our vision, is very excited, and I'm very happy to be here with you. Thanks for joining physically and remotely. So a little bit about my background. I've been working in software for the past 7 years, and the first work I ever did in software engineering was to try to accelerate Hadoop MapReduce job. I spent a few months writing a scheduler that should have accelerated it. It was a lot of fun. I learned a lot. Then I moved to AIOps, and today my team and I are trying to make Spark perform on top of data lakes and make sure that lakeFS fits well to your data stack. Before we begin, do we have data engineers at the audience? Okay. So how much time do you spend validating the quality of your data and working to improve its quality? How much time? Not enough. Okay. Would you like to reduce that time and to improve the results of your work? Yes. Okay. So what I'm going to do in this session is to walk you through a very structured way you can follow to get there and hopefully make sense out of your data lake. As data practitioners and engineers, so we got used to production surprises. I guess that it happened to most of you that you happened to make a change to your data pipeline, then tested it to the best of your ability, and then deployed it to prod. Finally, you ended up waking up in the middle of the night from a phone call telling you that production is on fire. And the issue could have happened because some use case we didn't expect it, or the data itself changed, or our DAGs were broken in production, and so on and so forth. I can go on for hours. And what we do in such cases is that we start troubleshooting issues that we have no clue about, improvising our way to a solution. So some of the things that could happen, some EMR, Spark, Databricks upgrades that lead to unexpected results, or some schema changes that broke things downstream, some like column rename that you did and it broke some select statement downstream, or you changed something in your infrastructure, you've upgraded a Python version and some packages broke, or you woke up in the morning and saw all of your Airflow DAGs colored in red, and while rerunning it, the issue did not reproduce. Another thing that could happen, and probably is a very painful one for all of you, is maintenance of legacy code. You know, this like ancient code that someone wrote years ago, and it's really hard to maintain, and it's full of joins and CTEs, and you have to go and fix the bugs there. So how do we get to that situation? So what I'd like to do is to talk about data lakes today. The best practice in the industry is to have data lakes run on top of an object storage. And when you run it on top of your object storage, you have like one large centralized repository with a very rich ecosystem of tools that are producing, modifying, and consuming data into, within, and out of the lake. So for example, streams that write raw data into the lake, or ETL pipelines that optimize data within the lake, or BI tools that consume data out of the lake. And it's great architecture, and it allows you to store tons of storage at an affordable cost, and you get this really great and high throughput. And it sounds pretty much ideal, but in reality, it also creates quite a few problems. Because now you have this like one huge centralized repository that has multiple moving parts and becomes a huge shared folder that is very hard to manage. So we work on top of this complex system that has multiple moving parts. And what we want to do is to make change to our data pipeline. Say I want to change job 6 out of 20 Spark jobs I own and tune its performance. How do you test such change today? How do you do that today? and say that I'm not even working on changing my code. So the data constantly changing underneath my feet. And even if I test things perfectly, which is very hard to do today, bugs still happen. And what happens if you find out that you have to revert data back? How do you do that today? How do you do that today? Okay, it's tough. We'll talk about it. So, and excuse me for complicating things a little bit more. It's not like there is one data engineer that owns the process from dev to prod. So the coordination not only has to happen at the data level, but also at the human level. The result, it's very difficult to keep the data quality high, and the cost of error is extremely high. So what do we do today to mitigate that? So part of us are guilty in deploying changes without testing them. I'll ask you, and please be honest here, who ever deployed a pipeline change into production without properly testing it? Okay, an honest audience, thank you. I appreciate that. So did praying help? I'm not sure. So, and in the good cases where we do our best effort to test our data to test things before we deploy them to production, so we create data copies, trying to create environments to test our changes in. So due to the fact that data lakes are usually very, very large, so copying the whole data lake is a very, very much time-consuming effort. So most times we end up sampling data and making copies of part of our data. And in general, copying data creates multiple problems. So first of all, this is a manual error-prone process. Second, we end up with multiple copies of our prod data, which may lead to compliance issues. And more than that, it has a very high maintenance overhead because the data continues to change all the time. So if you want to maintain your environment, you must copy the data over and over again. And in the good case, we also unit, integration, end-to-end test our data. And the input for our testing is usually not reliable, and it doesn't mock either the scale or the data characteristics well. And in case of an error in production, so we're staying strong and troubleshooting a way to find out what was the data in error, how did it happen, and the worst, we're finding ad hoc solutions to recover from the problem. And those solutions sometimes take days to implement. So I'm going to give you an example that most of you are probably familiar with, but did anyone hear about the recent outage Atlassian had? Okay, so it's a very traumatic one. So what happened recently is that a faulty script accidentally deleted 400 of their customers, and it took them 14 days to recover the data for those customers, and they couldn't fully recover it. There were some caveats to it. So I suggested we can do better, for sure. So as data engineering suffers from these problems, in software engineering, those problems are already solved. Every software engineer has a clear set of best practices and tools that support them throughout the software lifecycle. I'm going to ask your software engineer alter ego a question. So what would you say if I told you that you can no longer version control your code? Or test a code change that you're making before you're deploying it to production? How would you feel about it? Would you be okay with it? I don't think so. So what I'm saying is that this is currently what we do with data, and we can definitely do better. And I'm asking, why are we okay with it? So the good news are that we can apply engineering best practices to data engineering and manage data the same way we manage code. So let's see how engineering best practices apply to data engineering and how we can use it to improve the whole process of data lifecycle management. So I'm going to take you to a journey from zero data manageability to CI/CD for data. And what I'm going to do is focus on the first stop and demonstrate how you can easily create isolated data dev test environments. And then I'm going to show you briefly how we can walk all the way and get to the final destination. So to create isolated data dev test environments, the very first thing we want to do is to version control our data. And the immediate value that we get out of sticking our data into a version control system is that it unlocks collaboration. So now you and your colleagues can easily collaborate on data environments without stepping on each other's toes. And when you version your data, you want to version the whole lake, not at the object level or not at the table level, as some well-known table formats suggest. And by that, you get to add a semantic layer to your data lake that helps you understand what data was there, when, and why. lakeFS is an open source version control system that lets you do exactly that. Think Git for data, only that scales for hundreds of petabytes of storage. lakeFS supports, the open source version of lakeFS supports S3, Azure Blob, and GCS, and every S3 compatible storage. And lakeFS is also available as a managed offering for AWS users. So let's see what lakeFS is and how does it work. So basically what lakeFS do, it sits on top of your object storage and it enriches it with capabilities, with data versioning capabilities that we believe are missing from an object store, like branching, commit, merge, revert, and so on, all available via API, UI, and CLI, which makes it very easy to automate data operations. Your current application data stack can continue to access the object storage as it did up until today, or it can access your storage via lakeFS, enabling version control on it. From a technical perspective, the only difference is that instead of referencing the object storage URI directly, you're now going to need to mention the branch or the commit ID of the objects that you're trying to point to. So now, let's see how we can use lakeFS to create isolated dev tests environment. And so to do that, we're going to use a single yet very powerful operation lakeFS offers, which is create branches. And this operation takes milliseconds to complete since it's a metadata operation, and I'll get into it later. So by letting your users access to lakeFS repositories and letting them create their own lakeFS branches, we immediately unlock collaboration. As data engineers that sometimes spend long time making data accessible to your end users, giving them autonomy can save you a great amount of time. Data teams using lakeFS branches can use them to create dev test environments according to their use case. So let me give some examples. Say data engineering teams can decide that they only want to ingest validated data into their data lake. So to do that, they would create dirty ingest branch and only ingest new data onto that branch and introduce it later to production after validating the data. Another example for how one can use lakeFS branches to create isolated dev test environment is for experimentation. So remember the pipeline change that I wanted to check before and I couldn't? So now what I can do, I can open a lakeFS branch and experiment on top of it. I have access to my production data and I'm trying my code changes and testing its actual effect on production data. And then when I'm confident and comfortable with this change, I can decide on the next steps. Another example for using lakeFS branches for experimentations would be for data science teams or research teams that might want to compare the results of multiple experiments to each other. Say that you want to tune a machine learning training algorithm, and you want to compare the results of 2 versions of your change. So you can branch out of production and create 2 branches, experiment with your change, and compare the results. Once we're done working with our lakeFS branches and those isolated environments, we need to decide on the next steps. So the first thing we could do is to delete the branch. And I would want to delete my branch in case that the data was invalidated and I don't want to introduce it to prod. Or when I would like to introduce a new data set or when I made only a code change and it was a temporary testing environment that I no longer need. Like in our example of the pipeline, I tested my code and I no longer need my branch. The other option that I have, in addition to deleting my branch, is to merge my branch onto the main branch that typically represents my production data, my gold environment. And I want to do it in case that I want to safely introduce new data set into prod, or I already did some long process and I just want to introduce the data right away to prod and I don't want to copy data. I already ingested the data to a branch, so I can simply merge the data and it will appear on production without me having to copy it over and so on and so forth. So now, after we've seen what lakeFS do for us, let's take a sneak peek under the hood and talk about how lakeFS does this magic. And this is a teaser for Barak's talk, so I'm going to be very brief about it, and you're going to hear about it from an expert in a few minutes. But at a high level, to version control your object storage, what lakeFS does is it manages metadata. And lakeFS commits are a set of pointers to objects. And what we do is copy and write, meaning only when a new object is created, we're pointing to it. Due to this design, we get first very, very fast operations, like create branch, because they're metadata only operations, so they take milliseconds to complete. Second, we get phenomenal performance over very large lakes. Due to the nature of data lakes, they don't change as a whole on a daily basis, like a very small subset of the data changes. Therefore, some trivial operation lakeFS supports are very fast due to our design and data model. And third, object storage is cheap, but it's not free. So by using lakeFS branches to create isolated test environments, you get to experiment on production data without copying data, therefore saving on your cloud costs. Now let's see it in action. I'm going to pause and show you a brief demo of lakeFS before we go back to our journey. And what I'm going to do, I'm going to use the Databricks notebooks and demonstrate how I'm going to use lakeFS to create an isolated dev test environment. So this is lakeFS. Welcome. This is lakeFS Playground. You can spin it up in one click and you'll get an environment that is ready to use in 30 minutes, and it's yours for 7 days for free. And this is my Playground instance that I've created. And what I want to do right now is show you how we create an isolated dev test environment. I'm going to remind you that all the lakeFS operations are available via API, CLI, and UI. And during my demo, I'm going to use the Python client that we support, and the UI. All is available also via CLI. Okay, so the first step, I'm going to create a Python client instance. And I'm using the credentials for my Playground instance. Now, as you saw, I have one repo in my environment called my repo. And I'm going to create a new repo called Big Things Meetup. I'm defining here the repo name and the storage namespace for the repo. And what the storage namespace means is basically the location on your underlying storage where the data itself will be stored. So I'm going to run it, and then we'll see. OK, so now we've created one new repo. Let's refresh. OK, so we have our new repo, and by default, it creates with the main branch that, as I said, we usually like to think about it as the branch that we would use to store our production data or gold environment data. And now I'm going to use the UI to upload a CSV file. So I uploaded a CSV file, and if you look at the uncommitted changes of the lakeFS UI, you can see that indeed I have a new CSV file here. And now what I'm going to do, I'm going to commit my changes and attach metadata to my commit. So here I'm committing and saying that I added my first file, and I'm doing it using the lakeFS UI. Let's do that. Great. Go back to the UI, look at the commits. We have one new commit with the CSV file that we've just added. Now, what I want to do, I want to read the CSV file, and I'm going to use Spark to do that. Then I'm going to manipulate the file and rewrite it to another branch. So let's start by reading the file, and to do that, lakeFS integrates with like any application out there which is S3 compatible, but Spark is a very common use case for most of our users. So the first thing I'm doing is setting some Spark properties to connect Spark with lakeFS. Let's do that. Now I'm going to read the CSV file I've just uploaded and show it here. OK, so we've read our CSV file, and let's start experimenting. Reminder, we wanted to create an isolated environment for experimentation. OK, so let's see what branches do we have right now in our repo. I'm going to list the buckets on my repo. And I have only one branch, which points to this commit ID. And what I want to do right now is create a new branch that will act as an isolated environment for my testing. And then let's see what happens. I'm gonna create a new branch sourced in main, and I'm going to call it experiment 1. Great, so now let's list again our branches in the repos, and let's see that we have 2 branches right now. And as you can see, both point to the same commit. Again, creating a branch is a metadata operation. We only create a pointer to the commit that was there on the main branch. Now what I'm going to do is start with some manipulation. I'm going to repartition the data and rewrite it to my experimentation branch. First, let's partition it and then write it. Great, the Spark job completed. And now I'm going to show you things on the UI view, and then we go back and see it in the API. So now here I'm on my main branch. I'm not seeing the repartition data. But if I move to experiment 1 branch, so I see the new data that I added. And of course, it will be on my uncommitted changes section of the environment. Let's see it here. To view the uncommitted changes on the branch, I need to diff with the branch, similarly to Git. And we indeed see that the diff between committed and uncommitted is exactly what I wrote. Now let's commit the changes that we made to experimentation 1 branch and add metadata to it. Great. So now let's look again and view the commit chain. So we have 3 commits. If I go back to my main branch, I see that I only have 2 commits, meaning I'm working in isolation. I'm doing no harm to the data stored on my main branch. And finally, I'm going to diff between the experimentation branch and its source branch to demonstrate what I just told you, that things stayed only at my experimentation space. And this is indeed the diff, the partition data. So now we're done experimenting. As I mentioned before, we have 2 options. Either delete the branch if we no longer need it, or merge it back. And in this case, I'm going to simply delete my branch. I don't need it anymore. And Let's do a final branch listing, see that we actually deleted the branch. Great. Okay, so that was lakeFS. In short, it can do much more for you, but let's go back to our conversation and to our journey. And after we've seen how we can use lakeFS to create isolated dev test environments, I would like to take you back to the journey we started and show you how you can use lakeFS to integrate automated quality tests in your day-to-day work and your data lifecycle management process. And as you already figured, what Git is for code, lakeFS is for data. And as such, lakeFS allows you to automate checks and validations that are very similar to the concept of GitHub Actions. And those validations, they run after some appropriate events in lakeFS happen or trigger. And lakeFS webhooks that implements this functionality, they run on a remote server. And basically, they're guaranteed to trigger every time the appropriate event is triggered. And examples for hooks that lakeFS support is pre-merge, pre-commit hooks, hooks after creation of a branch or deletion of a branch, or tag, creation of a tag or deletion of a tag. And by leveraging hooks, you can basically implement CI/CD pipeline on your data lake. And I'm gonna show a few examples for it. So to create lakeFS hooks, what I need to do is to upload an action YAML file onto my lakeFS repository. And this action YAML file includes, first part would be the precondition that defines on what event the hook will trigger, on what lakeFS data versioning operation it will be triggered. And the second part says what hooks to run. Now, a very common use case for this functionality would be to set some ground rules for what are the formats that are valid in your lake. So in the example that you can see here, so what I'm doing, I'm making changes on an isolated feature branch, and I'm adding new data. And as part of my change, I'm introducing 2 new Parquet files, which are okay for my lake, but I'm also introducing a single CSV file, which is invalid as per my definitions. So to enforce that, what I'm going to do, I'm going to create a pre-merge hook that will be integrated into my lakeFS environment, and it will prevent from the merge operation to succeed. Basically, it will fail, and files that are not, file formats that are not allowed in my lake will never get there. So I'm going to show you a few more examples of hooks, and at a high level, just to say that we support pre-operation hooks and post-operation hooks. And pre-operation hooks are usually used as preventative actions, and they intend to prevent bad things from happening, while the post-operation hooks, they have like two main jobs, I think. So the first thing would be to notify an event and then trigger a chain of events, or just to run a process after an operation had happened. So this is an example for that case. So here, what I'm doing, I'm using lakeFS hook to create a dev environment which is free of PII. So what I did, I created post-create branch hook, and I defined that every time I'm creating a lakeFS branch, so there is some process that runs and cleans up the data that are available for my branch from PII. Another example of a pre-merge hook that you can use is basically to integrate quality checks into your data lifecycle management process. And when I say quality check, there could be custom quality checks that you implement, or well-known data quality tools that you use on your day-to-day, such as Great Expectations, Monte Carlo, etc. You can integrate them onto your data pipeline, data lifecycle management process. So with a little help from lakeFS, we completed our journey, and we've achieved CI/CD for data. And I'd like to recap and talk about the future of data lakes and about how data lakes look like when lakeFS is in the picture. So as we've seen, lakeFS is an open source version control system that can support you throughout the process of data lifecycle management. And with lakeFS, I can now safely make changes to my data pipeline. I can tune the performance of that job and then safely test it on an isolated environment. I don't have to copy any data for it. I just create a lakeFS branch and I test it over and I'm confident. Then I can arm production with integrated quality tests. And I can be assured that only quality data gets into my production environment. Then finally, when an error occurs, and error happens, we can never avoid it fully, I can easily roll back. And do you remember that Atlassian example that I told you about? Imagine that a 14 days process could have turned into a single revert operation that takes a few milliseconds to complete. That's what lakeFS can do for you. So thank you very much, everyone, for listening. I'm very happy to take questions, and we'll be happy to see you joining our community. Questions? So the question was, if we go back to the emergency incidents that we've talked about, what would we recommend to do with lakeFS? Would we simply revert as a first step, as a best practice? So I think that lakeFS gives you tools. It gives you also lineage. You can see what was there, and then you can use your judgment to see if the immediate action that you want to do is revert. For example, if you see that some new data was committed since the last time that it was healthy, so yeah, I would revert it right away. But if you see that something, it gives you a tool to see the history, to see what happened, and then you can easily decide yourself. But yeah, to recover from quality issue, when you know that the data lake was healthy at a certain point in time, I would revert immediately. More questions? Yes. Okay, so let me just clarify the question. So are you asking about the compaction of the metadata that lakeFS manages, or the data itself, the retention of the data itself? Okay, that's a question I'm very happy to answer for personal reasons. So basically what lakeFS has, we have a garbage collection process that we support. This is basically a Spark jobs, and you can define the retention rules for your repository, and all you have to do is soft delete objects, and then when you run the garbage collection process, it hard deletes the objects. So basically, it's not a one-way ticket. You can upload data and then use retention rules to clean it up from the underlying storage, according to your policy. Then you can keep compliance policies because you don't want to store PII for a long time, and so on and so forth. Okay, so I'll repeat the question. So the question was how we align, given that schema changes and data changes, they don't happen together. So how we make sure that we don't commit invalid stuff into prod? That was the question, right? So I think that you answered it yourself. The lakeFS hooks mechanism is a very, very good answer for that. What you can do, a very common use case that we see is that our users, they define a schema validation hooks that assure that you only commit data that has a certain schema onto the lake. So this is one way I would use to gatekeep and to basically match this potential inconsistency. Okay, so I'll repeat the question. So the question was if we're thinking about integrating Git with lakeFS somehow, and basically the goal is to tie code changes to data changes and to help us figure out what code change resulted in a change which is undesired in our data or desired. So yes, so we hear it a lot from users, and our most basic recommendation would be to use the lakeFS commit metadata to solve this problem. And basically the most trivial answer would be that when you commit your data, you can basically keep the hash of the git commit ID of the code that generated the data, and then you have this alignment. But we're very open to implementing something more formal and structured in the future, and we're happy to hear about the concrete use cases. If you would like to share later, we're happy. Any other questions? Yes. So the question was whether it matters what types of objects, what object format is there for lakeFS to version control it. So the answer is it doesn't matter. lakeFS is agnostic to formats, and we basically version structured, semi-structured, unstructured data, everything as a whole. More questions? Thanks, everyone. Pleasure to be here with you today. And we'll take 3 minutes, and then Barak will start with his next talk about how lakeFS internals are implemented.